So I'm going to show you how to do factoring a trinomial. It's a little bit more difficult type of factoring. And I'm going to show you two methods to do this. The first one is called trial and error. Not a very good name, huh? Well, it means that we're going to try different ways to factor this down until we hit the one that actually works. So let me do it wrong a few times so I can show you how we're going to do it, and then we'll finally hit the right answer. So I want to factor down this trinomial, but the difference between this one and some of the ones we've done in the past is that this has a coefficient of 3, which makes it more difficult to do. I could check if I can factor out a common factor, but 3 isn't going to go into 10 or 8. So there's no common factor I can take out. So what I'm going to do is try different combinations that might work. And usually if you don't mess with the first one, leave it 3x and x, and just keep doing that all the way down. Otherwise, you're going to repeat combinations that you already tried. So I'm going to do 3 and 8, and I'm going to try putting numbers in here. And to get an 8, I'm going to try an 8 and a 1. Then I'm going to multiply the outsides. That'll give me 3x. And the inside, 8x. But if I added these together, I'd get 11x. And I need a 10x. And if I subtract them, I get 5x. So that's not going to work. So this combination doesn't work. Okay, so I try another one. 3x and 1, x and 8. Well, here the outside gives me 24x and the inside 1x. And then I want to combine them either by subtracting or adding, but there's no way that's going to give me a 10x. It has to give me the middle term. So we see that doesn't work. Okay, 3x and x. How about 4 times 2? Okay, so we get 6x and 4x. And that does give me a 10x. And these would both be positive, huh, to get a positive 10x. But these two numbers are going to multiply to give you a positive 8, and you want a negative 8. So this combination comes pretty close, but it doesn't quite work. It's like putting a key into a lock, and there's only one key that's going to work. And this key might fit into the lock, but it's not going to turn it. It's not quite enough, see, because I need this negative 8 and a positive 4 times a negative 2, a positive 2. This would have to be a negative 2. But if it was a negative 2, then that would give me 10. So let's try one more combination. Let's try 3x and x. And you can see I didn't change the first terms, kept them the same. And now I'm going to use 4 and 2. I'm going to switch the 2 and the 4. This will give me 12x and 2x. Well, that looks like 14x, but what I'm going to do is subtract. 12 take away 2 is 10x. So the outside that gave me the 12x was positive. 3 times 4 gave me 12. And the inside, 2 times 1, is negative. See, that gave me 12x, a positive 12x, a negative 2x, and I get my 10x. And then a negative 2 times 4 is a negative 8. Well, this is what we call trial and error. And sometimes you can see that it's easy sometimes to make a mistake. Like this was pretty close to the right answer. This is the right answer. But, and you probably might not have tried 8 and 1. It's a long shot. This is probably a better combination to try. But the only problem is, You might try this one first and think you got it, and then you don't have the right combination. There's only the 3x and the 2 have to be together, and the x and the 4. They could be switched. You could have x plus 4 and then 3x minus 2, but you have to have those two things. So I'm going to show you another method to do this. This is a method that used to be used in some books. You don't see it too often. They use it in China. They use it in lots of countries, except for the United States for some reason. So to do this, I'm going to use my X box like I did before. The only difference is I'm going to multiply my 3 times the 8. I'm going to multiply this first term times my last term and put it up here, along with the sign, negative 24. And then I'm going to put the middle term over here. That way we have everything organized. So outside, I'm going to multiply these two terms together. That's my term here. And then I'm going to put the 10. Now I'm going to get out my sheet, which I have handy here. And I'm looking at combinations. I made 24. Where are they? Oh, they were over here someplace. Okay, here's 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Well, 4 and 6 might work, but then they'd have to both be negative, and that would give me a negative 24. So I'm going to use the 12-2 combination. And remember, if this term up here, this top term, if it has a minus sign in front, a negative, then that means we're going to subtract. So 12 take away 2. If it has a positive sign, that means we're going to add. But in this case, we're going to subtract. 12 take away 2 is 10. So I've got my combination. Now what I'm going to do is a little bit different. When I write this down, because I used the 3x squared, I have to write 3x, 3x. I have to write that down twice. This is kind of an intermediate step. Then I'm going to write down my plus 12 and my minus 2. Okay? Now, I know that this, if I FOIL this, I'm not going to get this answer. So what I have to do is I have to reduce. Sometimes I can reduce both terms. In this case, this is a 3 and a 12. I have to divide both of these by the same number. So I'm going to divide both of these by 3. 3 into 3 is 1. That'll give me x. 3 into 12 is 4. Then I look here. Is there anything that would go into both of those terms? No. So this is my answer, 3x minus 2. And that was the same answer we had come up with. So this is a technique we use where you don't have to think, you don't have to, well, you do have to think, but you don't have to try so many different combinations. It kind of cuts down a lot of the busy work. Okay, let me give you another one here. I'm going to grab this one from the book. Now, it's possible that you could have an x to the 6th. That is possible. But most likely it's not going to happen. So if you look, we got 6, 5, 4. That means we can factor out an x. And if you look over here, maybe there's a number that could go into all these. 57, not a very common number, but if I look at my chart here, 57, well, I could factor out a 3. And I can take a 3 out of 18 and a 3 out of 30. So I'm going to take out a 3 and then the smallest exponent, x to the 4th. So that's going to give me 3 into 18 is 6. 4 from 6 is 2. I'm going to do some basic factoring. 3 into 57 is 19. 4 from 5 is 1. 3 into 30 is 10. 4 from 4 is 0. So you should see that these are kind of x squared, x and a number, and we divided them all by 3. So we got a common factor. Now I'm going to see if I can factor this down. All right, so I'm going to write my x backs. I'm going to multiply 6 times 10, 60. And I'm going to put a negative 19 here. Now, see how this is a 60, this is positive. So that means I'm adding these two factors. So let's look at 60, see what kind of factors we might get that would add up to 19. 6 and 10, 16, 5 and 12, 17, 4 and 15, 19. Okay, 4 and 15. But I need a negative 19. So both of these have to be negative. A negative times a negative is a positive. A negative plus a negative is negative. This way I know I've got the numbers that'll give me 60, and I also have the signs correct. So when I write this down, I'm going to bring down the 3x to the 4th. I'm going to write this as 6x and 6x, but this is just an intermediate step. Minus 4, minus 15. Just put those numbers in. Now reduce them. I can reduce this by 2. It's always going to be a small number. So 3x to the 4th, I'm going to write that down again. 2 into 6 is 3, 3x. Don't forget the x. 2 into 4 is 2. This one I can't divide by 2, but I can divide it by 3. 3 into 6 is 2x. 3 into 15 is 5. It's got to be the same number in just 6 and 15. And there's my combination. Now, how do I know if I'm right? I can just do a quick FOIL. 3x times 2x, 6x squared. Outside, minus 15x. Inside, minus 4x. Last term times last term, plus 10. 6x squared minus 19x plus 10. See, and it checks out. So you can always double check it by doing a FOIL. What you want to do then is make sure you cross this one out, because that was just a step to help you get to the final answer. Okay. So I like this method a lot. You know, sometimes we run into very large numbers and sometimes it's a little difficult, but for the most part, it's probably easier than trying, you know, this would have been a hard combination. You could have used 3 and 2. You could have used 2 and 3. You could have used 6 and 1, 1 and 6. 10, not too many combinations, 1 and 10, 10 and 1, 2 and 5, 5 and 2. But you still be trying a lot of combinations. So let's try another one, see if we can factor this one down. Sometimes they don't factor, you know, but we're going to see if we can factor them out. Let me try this one. This is example 3. 30m squared plus 23mn minus 11n squared. So this one's gonna, if you look in the book, they tried quite a few different combinations on it. They tried to come up with a winning combination, so it does factor. We're gonna try it by the other method, by this X method. Now, the disadvantage to the X method on this problem, first of all, is there a common factor? No, 3 won't go into 23. 23 is prime, so that's not going to help us. So we're going to multiply 30 times 11 to start off with. That's 330. And it's going to be negative. It's 30 times a negative 11. And then this will be 23. So I'm going to whip out my calculator. Hopefully I have it handy here. Turn it on, clear it out. Okay. So I'm going to try the 330, and I'm thinking of combinations that may make 330 And right away, I'm thinking 33 times 10. Because it ends in 0. And if I subtracted 33, take away 10, I'm going to get 23. Okay, so even though this was a very large number, it wasn't too hard to get this. So I want to show, let's see, I wanted a positive 23, so it's going to be 33 minus 10. That would give me the 23. Now, if I multiply, would that give me the negative 330? Yes. So now I'm going to write this as 30m times 30m. But here I'm going to put plus 33 minus 10. N. Better put the n's there, huh? So I factored it down, very large numbers, but I can reduce both of these, let's see, by 3. 10m plus 11n, and reducing these by 3, excuse me, 10m, no, I can't reduce these by 3, I can reduce them by 10 though. How about 3m minus 1n, or just n? That looks a little bit better, huh? Can divide both of these by 10. So this would give me my, let's cross this off. This would give me my 30m, outside negative 10, inside negative 30, positive 33, outside, inside. That'll be 23. And then the last term times the last term. And I factored it. And this is a fairly difficult problem to factor, because if you were trying trials, they didn't even list all the trials. My probably would have tried off on 30. If it started with 30, I would have probably tried 5 times 6. You could also tried 3 times 10. You know, probably wouldn't even tried 15 times 2. You know, so it's one, give or take. You know, one or another. It's just trying to come up with combinations. So let's try another one. This doesn't look like this is even going to factor. And sometimes that happens. You know, there's just, I don't think this is going to factor out, because this is such a big middle term. They're in descending order. Make sure you write them in descending order. Let's see, the only numbers that would go into 20 and 6 are 2. So we could take out a 2x squared, 3x squared minus, let's see, half of that would be 58x plus 10. So we got 30 here and a negative 58. Well, let's look at our factors. So 30, maybe it would work. I don't know. I don't think so. To get a positive 30, we'd have to add these 31, 17, 13, 11. No, this is way too big. So this problem is unfactorable, which means we just have to keep it where it was. And it kind of looked like it would be, because the numbers are so large that it doesn't look like you could ever factor this thing. Unless I made a mistake on this. Oh, wait a minute. Copied it wrong. This was an 80. Where did I get the 20 from? Oh, I guess I looked above it. Well, if this is an 80 and I took out a 2, that's going to make a big difference. This would be half of 80 is 40. 3 times 40 is 120. Yes, this might factor 120. So I need 2 factors. They're going to both be negative. That will add up to 120. So I'm thinking 2 times 60. 2 times 60 would have worked if This was a negative 80, and it is. Copied it wrong again. What is the matter with me? That was a negative 80. All right. So this had to be 60, take away 2. 2 times 60 is 120. Take back those words. Okay. This is 2x squared. It's going to be 3x minus 60 and 3x minus 2. 3x minus 60, I can factor a 3 out of both of those. When I take this 3 out, here's an interesting situation. I take the 3 out. What am I going to do with that 3? I'm just going to discard it. I'm going to take that 3 out, but I'm not going to multiply it by this 2x. I'm just going to reduce this by 3. So I'm not going to multiply this. This is still 2x squared. This is going to be x minus 20 and 3x minus 2. Let's see if that makes any sense. 3x squared, outside, inside, they both add up to negative 58. This would have to be a positive 2. What is going on here? Positive 2. That makes sense. This adds up to negative 58 and multiplies to give me negative 40. Holy cow. Multiple mistakes. Let's try one that I can do without making a big mess out of it. All right, let's try this problem right here. I'm just going to make up one. Can I take out a common factor? That's always the first question. Can I take out a common factor? No. All right. Multiply these two. Negative 72. Include the sign. Negative 6. Two factors that multiply to give you 72. 72 right here. Lots of factors. But they're going to subtract to give you 6. 8 and 9, 12 take away, is that 72? 12 take away 6, yeah. How about a negative 12 and a positive 6? That'll multiply to give you 72, and negative 12 plus 6 is negative 6. There we go. So this is going to be 8x and 8x. This is usually the biggest mistake, writing this, forgetting to write that down. Minus 12 plus 6. I know that's wrong, but I'm going to reduce it by 4. And I'm going to reduce this one by 2. And now I have it factored. Double check 8x squared outside, 3x inside, negative 12x. Yeah, that'll work. Negative times positive, negative 9. So I found out that when students do this by this method, they usually make us sign errors. They get the signs with the right numbers, the right combination, and everything else. Because later on, we have to do more stuff to these problems. But that's kind of the idea behind it. Let's try just one more. And I know sometimes when they go, like this one would be a good one because it's kind of, this one's really a good one. Let's try this one. 24y to the 4th plus 2y squared. These have to be in descending order. Minus 15. This one's a pretty hard problem. Definitely hard. So I'm going to multiply 24. This is the calculator that doesn't work so good. 24 times 15. 360. This is going to be a negative 360. And this is going to be a positive 2 here. So I'm subtracting the two results. Ends in 10, so I might start off by saying, what about, I'm going to jot it up here, 36 times 10. No, 36 take away 10 is not going to give me 2. So I'm going to take my calculator, turn it on, clear it off. 360, excuse me. And I'm not going to put in a negative. I could put the negative, but I'm not going to bother with it. I'm just going to put, because we know we have to subtract the 2 results. So I'm going to divide by 2, and we saw that's 180, take away 2. That's not going to work. 36, 360 divided by 3. No, that's not going to work, huh? We finally got the 360 divided by 12. Oh, by 10, excuse me. We saw that, whoops, 360 divided by 10. And we see that doesn't work either. So the numbers have to be fairly close together. Let's try 360 divided by 20. 18. There we go. So the numbers, because this is a small number, the numbers had to be close together. 20 times 18. Okay. So sometimes you do have to play around on this method. It's not perfect, you know. And I want a positive 2, so let's make the 18 negative. Would that work? Negative 360, positive 2. So now it's 24y squared plus, let's put that down twice, plus 20 minus 18. Okay, now I'm going to reduce these, and I'm not going to say the factor. I'm just going to reduce them. Let's see, what could go in 24 and 20? Probably 4, huh? That looks good. 6y squared plus 5. When you get through, you want to make sure that you can't divide this again. So that means you're factored all the way down. What about here? 24 and 18, maybe 3, maybe 6 would be better, huh? 4y squared minus 3. So this was a tough one, no matter how you tried it. 24, where's 24? 24 has quite a few combinations. You might have tried 3 times 8 or 2 times 12, and then 4 times 6, 6 times 4. Then you might have tried on 15. 15 doesn't have that many combinations, just a couple. So you can also do it, like I said, by trial and error. 4y squared, 6y squared. And then playing around, you need a 15. You probably think 3 times 5. But where to put them? You know, that's the question. If you put the 5 here and the 3 here, it might work. You put the 3 here, the 5 here and the 3 here, it doesn't. So it makes a big difference which parentheses you put them in. And then you would do your outside and your inside. And you have to make sure they're 2y squared, so this has to be a negative. What I don't like about this is that you don't see sometimes that this is the 20. This is your outside. I usually do that first. That's your plus sign, and this is your negative sign. Here you can actually see the numbers when you put them in. You see how I had these numbers here? I actually had them. Okay,